Beneath the ocean surface, hidden from view, lies one of humanity's greatest engineering challenges. A tunnel that will carry thousands of vehicles through the depths, resisting crushing water pressure, shifting sediments, and the relentless forces of the sea. But before the first steel beam is laid, a journey of precision, planning, and innovation begins. Mapping the seabed, designing every segment, and orchestrating a process so complex it seems almost impossible. This is the story of how an underwater tunnel is built, from vision to reality.
Before any construction begins, engineers and surveyors carefully study the coastline and the seabed. Using advanced sonar vessels, they map the underwater terrain in high resolution. Remotely operated vehicles descend into the depths, capturing images of sediment layers, rocks, and underwater slopes. Back on the survey vessel, engineers analyze the data using holographic models, examining fault lines, slope stability, and the safest path for the tunnel. Autonomous drones sweep the seabed, building a comprehensive 3D map that highlights both opportunities and potential risks. Every detail, from the depth of the trench to the soil composition, is meticulously recorded. This foundational phase ensures that the tunnel's route is precisely planned, minimizing risk before construction begins. Once the route is established, the design phase begins. Engineers create detailed computer models of each tunnel segment, specifying dimensions, reinforcement structures, and waterproofing systems. Materials are carefully selected to withstand immense water pressure, corrosion, and environmental stresses. High-density concrete, marine-grade steel, and composite membranes are tested under simulated ocean conditions to ensure durability. Every layer, from internal ribs to buoyancy modules and emergency conduits, is carefully planned. Laboratory prototypes are built and stress-tested, confirming that the final structure will endure decades of underwater pressure. This stage transforms theoretical plans into a practical, buildable design. Before the tunnel can be installed, the seabed must be prepared. Massive dredgers and excavators remove sediment and rock to create a trench of precise depth and width. Remotely operated underwater vehicles monitor the excavation, ensuring slope stability and proper alignment. Grab dredgers lift dense clay and rock from the trench, while specialized robots smooth the walls to prevent collapse. Sediment is transported away by barges to maintain environmental safety. Throughout the process, engineers track progress using 3D bathymetric models, verifying that the trench meets the exact specifications needed for safe tunnel placement. The tunnel segments are constructed on land in massive fabrication yards. Steel molds define the shape of each segment, while robotic welders trace precise seams along the curved shells. Workers install waterproof gaskets, buoyancy tanks, and internal reinforcement ribs. High-density concrete is poured and compacted, forming walls capable of withstanding extreme underwater pressure. Laser scanning and quality checks ensure every segment meets strict engineering tolerances. One by one, these colossal capsules are completed, ready to be transported to the ocean for installation. Placing the tunnel segments underwater is one of the most delicate operations in engineering. Each prefabricated section is lifted onto floating pontoons and carefully moved to the trench site. The segment is gradually submerged, with ballast systems and hydraulic thrusters maintaining perfect alignment. Laser-guided measurements ensure it aligns precisely with the preceding section. Divers and underwater robots confirm stability and position. Once in place, the segment settles onto the seabed, forming a continuous path for the tunnel beneath the water. After placement, segments must be joined into a watertight structure. Rubber gaskets at each joint compress to seal the connection, while robotic welders fuse steel rings to reinforce the bond. Diver teams install mechanical bolts using hydraulic tools, and vacuum systems remove water from the joint chambers. Epoxy and waterproof membranes provide additional protection. ultrasonic scans verify the integrity of every weld. The completed joint is tested against simulated water pressure, ensuring it can withstand the full force of the ocean above. Once the tunnel shell is secure, internal infrastructure is installed. Roadbeds, railway tracks, and drainage systems are laid along the tunnel floor. Power cables, communication lines, and emergency wiring are carefully threaded through conduits. Ventilation ducts, lighting systems, and fire suppression equipment are mounted and tested to guarantee safe operation. Engineers perform inspections throughout, confirming that every system functions correctly. By the end of this phase, the tunnel is fully equipped to handle traffic and maintain safety under extreme conditions. The completed tunnel undergoes rigorous testing before opening. Structural inspections include stress analysis, pressure tests, and vibration monitoring to detect any weaknesses. Emergency systems are activated, including ventilation, flood control, and fire suppression, to ensure complete operational readiness. Inspection vehicles equipped with LiDAR and thermal cameras travel the full length of the tunnel, confirming alignment, stability, and safety. Once all systems pass inspection, the tunnel is officially ready for use, providing a safe and durable passage beneath the ocean.
If you enjoyed, please like the video, subscribe and comment topics for next amazing documentary.